Assalamu alaikum. This is Mohammed Suhail, and today I'm going to talk about merge sort. Merge sort is usually faster for list as small as 50 elements, but this extra speed doesn't come without a price. So a merge sort needs some additional space to merge two lists together. So merge sort So Marsort is big O n log n in worst case, in definitely a lot better, a lot faster, big O n square in average case. So we're gonna study, discuss and analyze. So we're gonna study, discuss and analyze Marsort algorithm. So there's one prerequisite for this lesson. One should at least heard about recursion. So let's get started. So there is a given list of integer in a form of an array, something like 2, 4, 1, 6, 8, 5, 3 and 7. So these are indexes 0, 1, 2, 3, 4, 5, 6 and 7. So let's name this array type A. So here we have 8 elements. So we have to sort this list in increasing order. Let's say it's B. So the list should be rearranged like this. One, two, three, 4, 5, 6 and 7. So our approach for this algorithm is completely different as far as we are rearranging the elements or changing their positions only by swapping or shifting. So we are going to break this problem into subproblems. We have to do 3 parts here: divide, conquer and combine. So what's divide? So we have to divide this array into two equal halves. So we will find some middle position and we can say that at all the elements before this position belongs to the first half and all the elements after this position belong to second half. If the array would have odd numbers of the elements, one of the halves will have more elements than the other half. So here is the middle position is 8. So this is the middle position. So after breaking this array, we find two array. So one is 2, 4, 1, 6 and second is 8, 5, 3 and 7. So now we have two equal halves. Now think about this. What if we are able to sort them two halves, and let's say these two halves are entirely different arrays and they are created separately in memory by copying values from the original array A. If we are able to sort these two arrays, then we can merge these two lists together in original list in sorted order. Let's say this particular sub array is named R. This is uh, this is L and this is R. L for left and R for right. So L equals 2416 R equals 358537. So if we sort it, it will be 1, 2, 4 and 6, and it will be 3, 5, 7 and 8, because all elements in A either in left or right. So we can start at 0th position in A. At any point, the smallest element will be either the smallest unpicked in left or unpicked in right. Let's say in left 1 is the smallest unpicked, and in right 3 is the smallest unpicked. So what we can do is we can pick the smaller of the two smallest unpicked in left and right, and so here we have two candidates, 1 and 3. So between these two, as is the sorted part here. This is the sorted part here. Here we found the smallest unpicked is 1, and here we found the smallest unpicked is 3. So here 1 and 3. 1 is smaller, so we can write 1 at 0th position. Let's say 0th position here is 1, as it is 0th position. Let's consider this is the 0, 1, 2, 3, 4, 5. Consider this is 1. So we is 0th index, and now we can look for the number to fill at first index in A. If I have to write pseudocode to merge the elements of two sorted arrays into a third array, let's say we want to write a function named merge. So here is our merge function, and it will pass the array. Here we will use the vector array A, this for left and this for right. So that will take three arrays as arguments, left, right and the array, in which it should be merging two sorted arrays, left and right. So here is first we have to find out the length of left and right. So length of L equal length so here we are found out two length. Then I will take the variable that will store the number of elements in L, and another variable that store the number of elements in R. So I will take three variables, I, J and K, and initialize them to 0. Let's say I will mark the index of the smallest unpicked in L, and so here we should comment out here. It will mark the index of smallest unpicked in left and J will mark the smallest unpicked in R, and K will mark the index of the position that needs to be filled in A. Index of the positions that need to be filled in our main array A. So for example, so this code will go like, so there is a loop, we can use a while loop. If I smaller than length of L, I smaller than length of L, where length of L is the number of elements in left side. For I to be valid index, it should be less than that number, and same for J. J should be smaller of L length, right? So while both these two are valid, we can say something like this. If, so something like this, if left I means our first index will, if left I smaller than right I mean first position of J, like this. So we are comparing the smallest unpicked in left with the smallest unpicked in right. In this case, kth position, in this case, so kth position in I, we will write left I, we will write left I, it will be like this. Remember, we are overwriting A, and that's not a problem, and now I need to increment K, so it should be like this, and we should increment I also. If I increment K and need to go to the next position, also need to increment I to go to the next unpicked in left. If this condition is not true, if this condition is not true, and so we have to do something else, so we should write else A, so this condition is not true, and AK will be Rj. That means R of j smaller than L of I, and once again we need to increment K plus equal 1, and also need to increment J. So if we increment J, so it should go to the next unpicked in right. So this is the explanation of the first example. So coming back to our example here, I and J are both valid, and we will compare if L of I is less than or equal to R of J. So we are comparing here. So let's count out. Comparing here, if left side smallest unpicked element is smaller than or equal to right side unpicked smallest element. So well, yes, Li less than Rj, so we need to pick 2. So we need to go for first index and we need to increment both I as well as k. So it should be like this way. So after 6 has gone, we are done with all the elements in left. I is equal to k now. So here I is equal to k now, and which is not valid. So in the while loop, this condition I is less than number of elements L will be false. So we need to pick all the elements of other array and will rest of the position in A. After we come out this while loop, we can write statement like while I is less than number of length. So we can check whether there are leftovers in left, and we can do the same thing, and we can say A of k equals to L of I, and then we can increment I and k, and similarly we can do for j. So once we are out of this first while loop, only one of these two while loops will execute. So we will fill up all the remaining position, and finally we have a sorted A. So this is our merge logic. So let's do another pseudocode which is called merge sort. Which will pass only this array or vector array, you can say. First it will take the length of the whole array A. In the beginning we had imagined that if somehow these two subarrays are able to sort this list, we can manage them back into the original. So this particular function call with this array with 8 elements as argument is passed, and this machine says that, hey, let me go and finish this particular function call and I will back to you. So it will be like this. If n smaller than 2, that means, and if n is 1, then it will return. So there is nothing to sort out. So then we have to find out the mid position, which is x. If we use vector like this, then we have to find out the x dot size by 2. Here is there we consider this array, so it's n by 2. So we have to find the left side. It's the size of mid. Should be 0 to mid, and the right side should be mid to size. So here is another for loop. Here is another for loop. Suppose we can take it I equals 0 to mid minus 1 it's only for left side, so left should be left I equal a I. As I told before about it, I will explain later again. So here is another for loop, that's for right side. It will go for mid to n minus 1, I mean size minus 1. Okay, so it should be like this. So right side it will be I minus mid equals AI. So after done with this, we can recursively call the merge sort for left, for right, and for the whole array. So here is left, is for right. Here's some syntax mistake. That's a pseudocode. I will explain it in code later. So there is another function which will pass all a left, a left, and right. So here is the main logic here. In that case, we need to pick all the elements of other array and fill rest of the position. After we come out this loop, we can write statements like this. So this is our main merge sort pseudocode. So let's go see the time complexity here. So let's say the time taken for an array of size n by merge algorithm will be t of n. And let us now see how we can find an approximate expression for this t of n. I mean total. We always try to approximate the worst case, and we try to see the rate of growth of time taken for very high values of n, and then we try to classify the time expression as bgo of some common function. Here in this algorithm, let's say we are exactly for here we are executing n smaller than 2. That means n should be greater than 1, and this statement is this statement is simple statement execute in constant time. So this set of simple statement, this set of this is a simple statement. So this set of simple statement in the worst case will take some constant time. Let's say they are c1. So they all are c1 as we indicated here. These all are c1. So I'm telling again, as they are a simple statement. So they have simple operations like arithmetic or logical operations, assignments or comparisons, and simple statement executes in constant time. So this set of simple statement in the worst case will take some constant time c1. So if there are no loops or function calls and there are only simple statement, then the time taken will not be a function of the input size. So after that there are two for loops. So these two assignments here will have same cost, and then two loops together will run in time. So we say that they will together cost us some constant C2. Let's say, so let's write here C2, C2. So let's say C2 is the cost of executing one of the statements, then the cost will be C2 into n, as there are two for loops. Then we have this recursive call. So for this recursive call, merge sort for left, we are saying that we will take t of n time for merge sort for an array of size n. The left will be an array of size n by 2. So these will be t of n by 2 costs. This will be t n by 2 cost, and right will be the same, as is also recursive as left. So right will be same, t of n by 2. Then we have a call to merge. For this one, we will have to look at the merge function. So here is my merge function. So all merge function doing was, it was picking up one element from either left or right at a time and writing it in another array in all loops. Here loops were running for the total length of left sub-array plus total length of right sub-array. So in all loops were running for n times. It's for running for n times. So if you would analyze the running time for merge function also, it will be of some form like some constant time n plus some other constant. So for n greater than 1, as is n so here t of n, so here t of n will be 2 into t of n divided by 2, plus we can add all this cost up, two into t n by 2, here t of n equals 2 t n by 2 plus c2 . Let's make this for c3. Let's consider c3 also a constant, c4 also a constant. So if here, if n minus 2 or n equals 1, that is the only case that we will have. In this case, there is only one comparison and we return. So the cost will be some constant, and we can simplify this execution. So we simplify this equation further, where c plus n plus c no. So for very high values of n, so this constant term will be negligible compared to c2 into n. So in time complexity analysis, we are mostly worried about the rate of growth of function for very high values of n. So for the sake of simplifying our calculations here, we can get rid of this c1 and we can say that T of n equals 2t n by 2, and let's say we call this C dash n. So let's simplify this. If we simplify this, there is if we simplify, there is 2 into 2, there is 4t n by 2 plus 2 C dash okay, this will be C dash. Actually I can write it here. Okay, let's consider this C dash n. So after doing this, we can do it simple algorithm in 16t 4 C dash n. So if I have write this in form of some generic k, so this will be 2 to the power k into t. So here n divided by 2k plus k into C dash into n. So from this way we can do another thing. N divided by 2 to the power k equals 1. So 2 to the power k equals n. So k equals log n to the base 2. So it should be log. So I can write here the log. So it should be log n to the base 2. So we can use the n's value here, and we can lastly find out O log O and log n. So here O n log n means t of n smaller than or equal to some constant time into n log n if n greater than constant value n naught. So there is the main time complexity here. So as we know, this merge sort is way faster than any other algorithm. So it is O n log n in worst case is definitely a lot better and a lot faster, and its average case is O n square. So here is the code. I do it earlier. So here the main function, while it's true, so we implement a vector here using vector. So get input here, we do input, so user do input as many length they want actually. So if the vector size equals 0, so the program will break. Then x dot to string, it's a printable function. So merge sort here. So we will passing 3 arguments here. Here is a vector x which is passed by reference, and we explained before, one is left and another is right. If left is smaller than right, then we find out mid and we call the merge sort recursively. Then we are going merge sort. So here is a merge function which is called elements left, mid and right, and we do it here, and two for loop, and they will set the value for this. And here is the comparing by an incrementing here. So after all, it's save it. So that's all for me. Thank you.